Samson Meteor mic, yeah. All right. Well, so today I've just been doing streams about debugging the compiler, and where I left off, we had fixed a couple of bugs. But we'd started with a list of several, and now we're down to the next one. If you saw the first stream, I built a mechanism for scrambling the order in which the compiler processes things and controlling that. So there's a random number generator that'll like shuffle things around, and then if I reproduce a bug, I can pass the same seed in later to reproduce that random sequence and get the same set of results. And so when we run, for example, with seed 652, we get this error where I'll tell you what this error means before I go in and attack it. This is in the type inference phase of the compiler, which is what typer means. Both type inference and type checking happen there, as well as triggering some other stuff like specialization for polymorphic functions and stuff like that, resolving overloads, etc. Like all that stuff happens in here. Now there's certain operations where we assume that everything should be ready to go when we do the operation, so we do it. Well, before I say that, let me just say that it's a language with a lot of complexity built into the compiler to help ease the time of the programmer. So if I go, into a file, at top level in a file like this, we have all these declarations top level, like, hey, num game modes is the count of game mode dot names, which happens to be here. But it didn't have to be here, right? It could have been in any file anywhere in the program, and the compiler just figures that out, right? So, like if you mention this and you say, oh, I'm dereferencing that as .names.count, there's sort of a dependency between this variable num game modes and this thing, the game mode struct. And if this weren't here, if it were elsewhere, then the compilation of this thing would wait until we found this thing and knew what it was. And that's true between any two things anywhere in your program at all. So, what happens is when we're figuring out the types of things, one of the mechanisms for making sure that we wait is well, let's say we're going through this struct, and, well, that's a bad example. Oh, I don't know. Let's not get too specific, but let's just say, if we want to figure out the full finish type checking something, right, and it's comprised of other sub things, then we start doing the sub things one by one. And if that sub thing itself may be ready to be type checked or not. If it is, then we type check it and figure out the type and do all that. If it's not ready, then one of the things we can do is yield until later. Like, look, I'm trying to finish resolving the type of this thing, and we're trying to figure out state, but state depends on something, game state, that I haven't seen the declaration of yet. So I don't know what it is, so we can't finish. So we're going to yield this thing and come back to it later. And when I say yield, that's a term that tends to come from threading and stuff, but this isn't a threaded, this part of the system isn't threaded that way, because that would actually be bad. It's more just like there's an array of data structures that we're working on, and then we pull the first one off there, and we either finish processing it, or it tells us to yield, and we come back to it later. So that's the general mechanism. Now, once in a while, there's situations where we're like, okay, we're type checking something, and in order to finish doing whatever we're doing, we need to do something a little bit more heavyweight than usual, or a little bit scarier than usual. Like, here's a part of the syntax tree of the program that's already type checked, or we're ready to type check it, but we're going to copy that and make a little tweak, right? Like, that might happen if we're doing polymorphism or something, right? And in that case, for example, there's this idea, well, it should have been ready now for us anyway, so if we copy it, the copy should be ready. And I don't want to try to have to build into this routine enough understanding for it to deal with yielding or not. So we're just going to say we better not, none of the sub procedures that we try to call had better tell us to yield because we think we're supposed to be ready. So that's what this assert means. It thinks it's supposed to be ready, but it's not. So let's just, there's several cases in the compiler where that could be true. And I don't know which one this is, so we're going to go look. I'm going to run with that seed, 652, and there we go. So the whole point of that random seed thing was so we can make the same thing always happen at will, which we just did in the debugger. All right, so here's our assertion. Okay, we're trying to cast one thing to another thing, is what's happening. So let me go to the top of this very long procedure just to show you what it is. Oh, okay. Actually, it's a little bit different than what I thought. Okay, this is good though. So this is one of the very, very foundational procedures in the compiler for this type checking phase. And what it is like, look, let's check that whether two types match, right? So here's the type that I want, like maybe it's the type of a variable that I'm assigning or a parameter that I'm trying to pass for a procedure. And we figured out a type for what we're trying to pass, for example, as a parameter. And here's what it is. And okay, how do we decide if those types are compatible? Maybe the type we gave can be casted to what is wanted, or maybe they're exactly the same type to begin with and it's obvious, or maybe they're compound types, right? Maybe the given type is an array of 100 of a certain kind of struct, and wanted is also an array of something, but because an array of 100 of certain types of struct is starts to be a little bit of a complex tree. There's several nodes there. We have to start recursing down into the subnodes of each type and compare them and see if they're compatible, right? And while doing all this, this is also how we determine what the polymorph variables are if we're instantiating a polymorphic procedure. So if we give you a type that's an array of 100 of pointers to some struct, and what we wanted was an array of 100 of some type t, then in the course of this matching, we'll figure that out that those match, but that they match when t corresponds to pointer to some struct, right? And so this does that. So it actually does a lot. And anytime you have code that does a lot, it gets complicated. So let's see what's actually happening. Okay. There's this idea of, so we gave a pointer to some type, and it's a pointer to a texture catalog, actually, which is the thing that I use in the game to look up texture maps for rendering. And we wanted a pointer to an entity manager. Those are different things. So this should not match. We're probably testing an overload right now to see if we can call it. In fact, I bet it's init, because entity manager has an init and texture catalog has an init. So we're testing to see if we're going to call an overload, I would guess, and the answer should be no. And we're trying to figure that no out. So so each of these are pointer to things, and then these are just the things that we're pointer to. I gave short names to those. So find compatible anonymous member is a procedure that says okay, if I want I'm trying to think of an example in the code that I can show you. I bet I can just search for one. So so No, I'm just going to keep going. I'm going to search for one. All right, let's search for one here. Maybe I don't even have one. No, I must have one because I'm executing. We can actually, if I can't figure it out, we can just ask where this one is. Oh, you know what? Okay. There's several cases. So I'm trying to explain what this find compatible anonymous member is. And there's several cases where it comes up. And one of the simpler ones, actually, is a case such as the one we were looking at in the previous stream. So when we do something like this using, where we say, okay, this thing is an entity, but it's not only has this as a member, but using means you can refer to all the names of that member in this namespace, right? When you do that, you get an additional thing, which is that any procedure that you call that takes an undoable data as an argument, you can just call that on the entity, right? Sort of like you can with subclasses or superclasses or whatever of objects in C++, right? Like if you have a derived class, you can pass the base class to a procedure or a pointer to it or something, right? So that's the same thing. So this is one instance of a compatible anonymous member is if I'm trying to call a procedure and it takes an undoable entity data and I pass it an entity, then this is the procedure that would figure out like, oh yes, this is actually a compatible argument. All we have to do is take the offset of this member, right? So that's what this is trying to do. And what it's saying is, we're not ready. Which actually, now that I think about it, is not that surprising necessarily. Although, well, I don't know. Anyway, so we're going to do a trick. We're going to do a C++ trick, or a debugger trick, where we're going to continue on from this assert so that we just get out of this deep morass of Visual Studio code, or Microsoft Common code. And we're going to run back till we hit this breakpoint. Oh, come on. All right, well, let's do this. We'll set a breakpoint here on the condition yield. So that should fire before we hit that assert. Okay. And let's make sure. Yeah, so it seems like the same place, like there's texture catalog. Okay, so we're about to assert that we didn't yield. Right, so if I say not yield, it's false. So now, now that we know that this failed, I'm going to jump back here. I'm going to say set next statement. So I've modified the instruction pointer to point to this procedure again. This is one of the very valuable things you can do with a debugger that's very hard to do without a debugger. I've modified the natural flow of my program. And now I'm just going to go back down into this thing I just called and try it again. And I'm just going to watch what happens. So let's just see what this is. Given struct desk is bound name texture catalog. Okay, so for every member in texture catalog, we're going to look at it. And we're looking for one that was marked as using. So let's go look at the texture catalog for a second. That's in Sokoban, source, texture catalog. Well, we only have one member, and it's a catalog, and we're using it. So we're probably going to recurse on that one member, right? So it is marked as using, so we went on to this line. We didn't continue the loop. We say, has its type been checked? It hasn't. Okay. This is a little bit serious. Because this says to me, why are we doing this? We're not, yeah. Okay, I suspect I know what's happening here. So the problem is we're trying to compare this type text or catalog to see if it's a valid argument for an overloaded procedure. But we haven't finished type checking this. But for some reason, which I think I'll explain in a second, we don't have a dependency on catalog. If you saw the previous stream, I rambled a lot about dependencies, and I don't know how coherent that is because I was tired and because it's a complicated subject. But basically, this type text or catalog is supposed to have a dependency on this using and say, okay, this type is not complete, right? And we'll check this in a second, but I suspect it actually does have that dependency, especially because we just did some stuff related to that. What I suspect is that it has that dependency, but we're not waiting for it. And the reason we're not waiting for it is because at the calling site, is because we're passing in a pointer to this type. And let me see, so we tend to pass a site telling us where this is happening. So this is happening at line number 405 of file main. So let's go there for a second. 405, was that the number? 405. Okay, so this is where we are. So we're passing a pointer to a text or catalog. So here's the thing about pointers to structs. And it is that, in principle, a lot of the time, you don't need to, so pointers are all the same size, basically, right? So if you have a pointer, and all you really care about is like, how big is this struct or whatever, then if you have a pointer to a substruct, it doesn't matter like what the nuances of that substruct are. Like if you're sizing a struct, you just know that that pointer is a certain size and that's it. So we tend not to have a dependency there because it would block compilation of that type. Let me give you a conundrum, right? So let's say you've got a struct A, right? And it's got a pointer to B. And then you've got a struct B, and it's got a pointer to A, right? So we have to be able to compile this because this kind of thing happens all the time. And in this kind of a case, okay, A has a pointer to B and B has a pointer to A. So if they both waited for each other to be done, you would never be able to compile it, right? Because this guy's always waiting for this guy and this guy's waiting for this guy, and it's a mess. But what we do is we say, look, it's just a pointer. The size of A is the same regardless of what B is, right? Because it's just a pointer. And the size of B is the same regardless of what A is. It's just a pointer. So there's like a special case in that kind of type checking where if it's a pointer to a thing, you don't need to wait on the thing. Now, I have not thought super carefully about exactly to avoid these kind of deadlocks, when do you need to do this pointer fast path and when don't you? And the reason is just because it was never an issue before. So I think I do it all the time. Like, I think if, you know, I use a pointer to something in a procedure, but not the thing, that we don't wait on it. And the problem is, I mean, so now at this point, I'm getting into stuff that I probably haven't really looked at in a year, so anything I say may be a little bit wrong, but I believe well, I don't know. It's hard to say. Like, I don't even remember where this check happens right now. So to validate whether this theory is actually the case, I would need to figure out where this happens and check it. But first, I want to look at the data structures that are actually involved here and make sure that that's right. But what I will say is, so let's go back to main for a second and let's figure out what should be happening. So we're saying, okay, there's a global thing called texture catalog. Let's look at that. Right, it's of some type texture catalog. Very, very straightforward. And we're saying, take a pointer to that global struct, pass it to some procedure called find, of which there are several overloads on different things. So pass it to that, and pass the map name, right? So this is what this routine that we broke in is trying to do. It's like, okay, which version of find is the one that operates on this argument? And to know that, we need to really know what the type of the argument is and whether it's compatible with other stuff. And the problem we're having is that type, the type texture catalog is not ready. So we cannot, if it's a procedure that we're compiling, we cannot compile that procedure if we don't know the structs of anything that we have a pointer to. And that is true now, but in the earliest days of the compiler, we didn't have this kind of, oh, if it's a subclass, you can pass the pointer kind of stuff. So the earliest days of the compiler just treated pointers fully in the way that I'm talking about. So I want to validate that this is really the problem, because there's been enough confusion about that today, if not in general, because it's sometimes hard to tell. So I'm going to look at the data structures a little bit. I'm going to make sure that this is what's happening, and then try to figure out why it's happening and maybe fix it. So let's see. So what I should do is I should drop back and look at the lambda that we are passing, because that lambda should depend on texture catalog, and the theory is it doesn't, right? And the reason why I'm checking this is because so let's go back to texture catalog for a second. Something else could be, there's sort of a chain of dependencies that has to remain intact for this to work. And my theory is that the missing dependency is that the lambda doesn't depend on texture catalog. But it might just be something more like we were seeing earlier today, where it does depend on texture catalog, but texture catalog didn't successfully depend on the using, or the using didn't successfully depend on this declaration, or whatever, right? So if anything in that chain is broken, we won't properly wait until things are compiled. So something in that chain is broken. My guess is it's the very first link, so we have to check that. And that may be tedious to check, honestly. So we are So we're type checking one overload, right? So we've got, here's an overload we want to see if we can call. Here's the procedure call that we're actually, this is the procedure call expression. So if I go back to main, why am I in email mode? Main. So that argument call corresponds to this thing that says find of whatever, right? Now, what we want to do, we actually want to, the type that we want to check is, well, actually, no, let's just drop back. This is easier. So all of this is taking place in the context of we're type checking the body of this procedure, right? So I can drop way back on the stack, and this procedure is queued to be resolved just like any procedure would be. And I can drop back here and say, okay, queued, let's make sure it's the lambda. So this queued has an expression that it's representing, and what type is that? It better be a lambda, it is. So I can cast that to a lambda and make sure it's the right one, which it is. Whoops, not that, but just the expression. Okay. So it's a lambda, its name is setMap. See right there, if you can see that tiny text on the stream, but that's this one. So it's the right lambda, and so the same queued that points to the lambda should have a bunch of dependencies. And it does. Well, it's only 6, so that's not too bad. So let's pull this array down. We'll say comma 6 so we can inspect it. All right, so these are all the things. I'm going to start poking into this array. And these are the things that this lambda is waiting on in order to type check. And in theory, every single one of these things has passed the type checking stage, or there's a bug. But in theory, all of these are past the type checking stage of the pipeline. And then we just get to inspect what they are and see how it is. Someone's asking, could the compiler assume the pointing to type exists and check later once all structs have been defined? Well, that's sort of what yielding does. The thing is, you could imagine saying, well, like imagine for the sake of argument, this was actually a bigger procedure, like after this, it did a bunch of other stuff. You could say, well, this isn't ready, so we can't resolve this, but let's do all this stuff, and we'll come back to it later. I think in limited cases you could do that, but the reality is that very often, especially because we declare variables as being the type of whatever the right-hand side is, like all the time, very often you just can't proceed. Because if you don't know which overload this is, you don't know what the return type is. And if you don't know what the return type is, you don't know what this is. And if you don't know what this is, you don't know what anyone who uses it is, etc. So that is just to say, my policy is just, okay, if you hit something and you're not ready for it, just come back when you're ready for it. Because we're generally tackling things in order in a more atomic block of information like a procedure. Okay. So let's look at these. Now, the extra complicated thing is it may not be the right answer for there to be a dependency in here, because the type checking phase is the phase where I started switching a lot of things to yielding. So it might be that we should be yielding. You know what? Maybe I should just yield from this. Can I yield? I can. Well, okay, find compatible an honest member can check that types match yield, because that's kind of what I want to know. Okay, this does not have a mechanism for yielding. So it may be, so I just want to look and understand the problem clearly, but the right answer may be for this to be able to say, oh, we're not ready yet, you can't do that, and yeah, so that might be a thing. So going back to here, I believe type check arguments has an ability to yield. Yeah, we can say we're yielding upon this expression and we're not ready. So the broken link in our ability to yield is just that check that types match doesn't understand the concept of yielding. The thing it's calling understands yielding, and the thing it's called by understands yielding. So the only issue is that this doesn't understand yielding. And you know what? Okay, I'm gonna, like I said, I'm gonna just look and understand the argument or the problem better, but I'm pretty sure that my solution is gonna be to make this yield because, like I said, the dependencies, it's the way I started making the compiler. It's a pain in the butt, honestly. Now the thing about yielding is if you yield a lot, there may be performance implications of that. Like you may do a lot of work and then it gets wasted and then you have to do it again and again and again. However, I feel like the impact of that is actually relatively small. I don't know. I mean, we're gonna see, and we're gonna because it's, like I said, it's not a thread yield. It's not like we just pause what you're doing. It's not a fiber yield. It's well, you just couldn't do whatever you were trying to do. But if you had type checked 9 arguments and you yielded on the 10th one, then next time we process that procedure call, we're going to retype check all 9 arguments, etc. But in practice so far, it has not been an impact on compile time. So we're just gonna, I'm gonna continue making things work that way. I guess the other thing about yielding is I feel like it becomes less provably correct, because if you have a list of dependencies stored as data, you can run analysis on those dependencies in some way, right? Whereas if it's just code saying, yes, I'm ready, no, I'm not, you can't really prove very much about it. But provability is a secondary or tertiary goal compared to like just having something that works, right? I mean, I'm willing to rewrite the entire compiler again later in a different way once we've figured out what the language is and how the compiler, like what the features and the functionality of the language should be. So all I'm trying to do for now is make a stable enough compiler, well, stable compiler, but stable enough meaning I don't know if it's provable or not. I mean, no compiler of a non-trivial language is really provable anyway. So I don't want to rat hole on that idea. This is all just to say, I'm just thinking out loud. That's what's happening. I'm thinking out loud about what the ramifications are of making this decision in different ways. Okay. So like I said, I'm going to understand, I'm going to see if there's a dependency I'm going to make sure there's not a dependency to texture map in this array of dependencies. And then we'll go from there. Why not? That's just an easy first step. I'm pretty sure there isn't, but I've been wrong about these kind of things before, especially on streams. Okay. This one is a dependency on another lambda. That is probably it's probably some instance of find. Let's verify that. That'll be easy. So we're going to cast this expression to lambda. And its name is, oh, set map. Oh, right. Okay. So the thing is, to really understand what's going on, we have to check the flags. So every lambda actually has two queues. It has a queue for the header, which determines just, have we resolved everything that you need to know to call the procedure, right, from somewhere else? It's sort of analogous to what would be in the header file of a C++ program, because you don't want to force people to wait until you compile the full body of the procedure to be able to call it, because otherwise you'll end up in deadlocks very similar to that struct deadlock that I showed, but then there'll be procedures calling each other kind of deadlocks, and you need to be able to compile that. So every procedure has a separate entry in these pipelines for its header and its body. It's just invisible to the programmer, right? You never write a separate header. It just takes, you know, this part and says, okay, that's the header, and then takes this part and says, okay, that's the body. And then one of those waits on the other, right? So the body waits until the header is type checked, and then the header waits on the body later in the pipeline. I don't know, it's complicated. Anyway, so this queued that we're looking at now is 32 is its flags, which 2, 4, 8, 16, 32. It's a body of a lambda, right? 16 would be header of a lambda. So this is the body, and it's depending on the header, right? So this queued is for the same lambda. It's a good thing I checked because I was wrong. Well, oh no, that's lambda flags. So this dependency's target, this is the other queued, has flags of 16. So that's the header for this same procedure. Completely unsurprising, because we do that for every procedure. So dependency 0 is not relevant to our problem. Dependency 1, like I said, this might be a little tedious. This is that identifier map, which is a member of E, right? So let's look at that. So this is entity, right? Entity, remember, this is related to the previous thing we debugged, which is it's got this undoable entity data. Undoable entity data has a declaration for a thing called map that is a texture map. So when we see that identifier, then we need to kind of depend up that chain. But like I said, this isn't going to depend on the body of texture map. It's just going to, because it's a pointer in a struct. And we don't wait on that kind of thing. However, it may be that when you're a lambda and you want to run some code, if you depend on a pointer to a type, you need to also depend on that type. That may instead be the workaround, right? Instead of making that thing that we're calling able to yield. I don't know which of those is a better idea. They both would work, probably. They both would work. Let me write down, okay, this is useful because well, actually no. Okay, so here's the thing. In principle, we could fix this dependency problem in this location by when we look up e.map, we make sure we make a dependency on this struct. However, that would not really fix the problem that we're trying to solve, because the problem is really that we're calling this procedure, and we could do that without assigning the result to anything. In which case, this e.map would not be there to save our cheese. So even though this may or may not supposed to have a dependency on the thing, it's not the real problem. So we're going to pass this one up, and okay, no, okay, so the answer has to be yielding, like I said at the beginning, because here's what's going to happen. Imagine we didn't have this e.map here, right? So the way that we're supposed to depend on texture map then, in some way, is there's a bunch of declarations of find in the global namespace, and now that we're calling this and it might be overloaded, we have to wait on all of those. Or, you know, like, how are you gonna check all your overloads if they're not all ready, right? Even if you found one that was ready that matches, there might be another that's ready that matches better, or it matches the same, and you're supposed to issue a compile error that this is an ambiguous call. So, the thing is that there's already a thing that's supposed to say, oh, we're looking at the overloads and they're not all ready, and so we yield. So then, I guess what I'm saying is, putting a dependency on the lambda would not ever solve this problem, because the dependency is in find. It's really, if there's a missing dependency on a lambda, it's in one of these lambdas. Yeah, so I hope you guys are getting a feeling for how tweaky this part of compiler work can be. I don't know if I just sound like I'm just spouting gibberish the whole time, or does anyone understand what I'm saying? So let's pause a second for questions. Do people get this at all? Do people get 20% of this, or is it just noise? Yeah, this is a mildly off-topic question for what we're talking about, but yeah, we don't JIT code in the sense that you think of. I mean, we do, but we do to byte code. Someone's saying, if I'm just trying to make a correct compiler that may get rewritten later, why have all the parallel stuff in the first place? Isn't that premature optimization? Not really, because I have to, A, I have to use the compiler, and I want to be happy using it, but B, we have to validate the design, right? The speed is a deliverable of this compiler, right? Like, we not only want the language to be good, we want it to compile very fast. So when we're designing the compiler, we have to see if we're able to achieve that deliverable of compiling very fast. If we don't, then we have some rethinking to do. And so part of that is how amenable is compilation to threading. You know, I mean, we could not thread the compiler. In fact, it wasn't threaded at all till like 4 or 5 months ago or something. And it would still be fast compared to most compilers. But, you know, parallelism is important in modern computing, and we just want to make sure that we know. And also because I had fun doing it, right? So when I say like, hey, you know, we'll probably rewrite the whole compiler later, it's like, okay, that's true, but that later is 5 years from now, right, or something. It's not next year. so if people are going to be using this version for the first N years that they're using the language, it has to be good. So this is, this is not a prototype compiler, it's a real compiler. It's just version 1 of a real compiler. Let me put it that way. Can I explain the whole thing again? Nope. Gotta watch it again. Okay. Okay. Now, fortunately, we can go down to the overload that we are type checking. Actually, hold on. The problem that we actually, what I just said about the overloads is true in a sense, but that also will not save our bacon, because the overload could have like the base class of the type that we're passing. In which case, like if the overload is just on catalog, which it probably is, it won't have texture catalog. So what really is going on is when we resolve this identifier, it's really just this identifier that needs to, it doesn't even have anything to do with find, and it doesn't have to do with e.map. It's only this identifier, which is fine actually for us, because that actually simplifies it, because like digging through this procedure is like a whole other thing. But this one, let's just figure out what that identifier is, and then we'll watch what happens when its type gets inferred. So call, like I said, represents this procedure, right? And it's got a procedure expression, which represents find. And then it's got arguments, right? So argument list unsorted is where our arguments go when we pass them. And they're unsorted because, maybe the thing that we're calling has optional arguments. Maybe we're using named arguments and they're going to get put in a different order and stuff. So this argument list unsorted is just the arguments in the order that we gave them. So element 0 of that array is going to be an expression that says take the address of texture catalog. So if I dig into that expression, I can see what this identifier is and get its serial number, and then we can break on that serial number. So we're going to do that. So element 0 of the array, right, it's an operator expression right there. And let's cast to that. Sub-0 wins. Cast operator expression. Okay, so we will see it's a unary operator because it's got no left operand, it's only got a right operand. The token type is 42, which is ASCII for star. And the right expression will be, I'll check the type right now, it'll be ident, right? So right, it's an ident. And by digging in here, we can see the serial number, which is 14002. So sometimes, for a lot of these streams, when I work on the game, I use printf debugging a lot, but man, once you get beyond a certain complexity threshold, you really don't want to be printf debugging, and this is one of those things. Like being able to just inspect fields is very valuable, right? Where I get grumpy about is that Visual Studio doesn't help me see the relations of pointers between things, for example, which is super important in a compiler and many other applications like AI or whatever, and it's just in the Stone Age about that. So this ident, whoops, is 14002. I'm crossing out some old numbers of things so they don't distract me. Okay, so now what we're going to do is we're going to go to the clause in infer types that actually, there's a thing called resolve one ident. For any identifier, this is how we look at what it's hooked up to, and we add dependencies for it. So I'm going to set a breakpoint here, and it's on ident s is equal to 14002. Let's double check that number, 14002. Yep. So now we quit and we run again. And we're doing the same thing because we've got the same seed. However, because we resolve a lot of identifiers, this is a slow data breakpoint, so it's going to take us a while. I could have added an if statement, and yeah, but I didn't. Okay. Okay, so let's check that this is the right identifier. It is, so it's texture catalog. You know, I get so grumpy about Visual Studio. Like, it's so, the actual information that I care about in this mess is drawn so poorly. Never mind. Never mind. We're not gonna rant too much about that. They don't care. Okay. Texture catalog. So it's the right, that's all I wanted to check, is look, it's the right thing. It's not, we haven't resolved it to a declaration yet, so we don't know what this word means yet, right? And this is supposed to be the routine that tells us what this word means. Now, we may not be able to look it up yet. We may have to yield here and come back later. I don't even know, honestly. Actually, let me just hit F5 and see if we come back. No. Okay. So the first time we hit that identifier, we are ready to look it up. So now we're going to go back there. Now we're going to go back there. Oh yeah, the Super Bowl's this weekend. I'm not a football guy, so yeah. Super Bowl. Okay, so we're resolving this ident, and let's just see what happens. Well, we found a declaration. This may have done a lot of work, actually. This may have done the dependencies. I don't remember. So, although actually follow constant import targets does depend on things. Okay, wait. So now I'm wondering how this mechanism that I explained before of, you know, not really doing a full dependency if it's a pointer, I'm wondering how that actually happens. And I think there's like a flag. No, I don't know. So we have flags on the ast, and they're these. So I don't see anything there about we're taking a pointer of this thing. So I don't remember. We may just have to dig further into these things. Well, let's see this declaration. Oh, you know what it's going to be? Okay, so this declaration has actually already been compiled because we know it's, well, it's been compiled enough that we know its type. So putting a dependency or not on this wouldn't even matter. It's not what's causing our bug, because a dependency would not cause us to wait because it's compiled. The problem is, right, so this declaration is, let's make sure it's the right one. I'm pretty sure it is. It's at line 181 of main, right? So, oh, actually, I don't know which one that is. Oh yeah, texture catalog. Okay, this is freaking me out. This is freaking me out. Okay. 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 Here's the thing. This is where I realize things are actually even more complicated than what I explained. And this is one of those, what I'm going to say now is like potentially a questionable decision. It's from the early days of the compiler. And maybe I should be thinking about changing this decision today, because I'm not sure to what degree it makes sense or not. I'll just try to explain it, and in explaining it, I will try to figure out for myself if it makes sense or not. Changing it tonight would be a big, scary change, but hey, sometimes big, scary changes are fun. So when we make a struct type, okay, so we've got this declaration. It's a variable called lowercase texture catalog. It depends on uppercase texture catalog, right? Now, uppercase texture catalog is this thing on the left. And, you know, like I said, it's using the catalog, and it should be depending on that, and it totally isn't ready, right? When I make a new struct type, though, so this whole type checking phase that we're doing right now is supposed to be about like, hey, do you know what types things are, right? And when you make a struct type, way back in the early days of the compiler, when I added structs, it was like, do you know what a type a struct is? Well, yeah, like it's its own type that you're declaring right now. Like there's no, it's itself, right? And so when I make a struct, I actually set its type immediately. And what that means is that it's sort of red carpeted through the type checking phase without doing anything because its type is set. And if it's waiting on members and stuff, it's waiting on them so that it can be sized, which is the next pipeline after type checking and stuff. So we know what type a struct is. But that's actually not sufficient. I mean, we know what type in the sense that we know what node in the syntax tree represents the types for this thing from the minute we create the thing. What we don't know is the aspects of that type, like what can this implicitly cast to and things like that. All that stuff depends on this, getting resolved. So maybe I shouldn't set the type right away, and it should go through the pipeline like everybody else, and it should block on all its members and whatnot. But I'm pretty sure there's good reasons not to do that. Because, for example, that whole pointer thing I was talking about, remember when I said A pointer to B and B pointer to A? You don't want to wait on B and A in this case, but you do want to be able to type check that this is matches some other pointer or whatever, right? Otherwise, it doesn't mean anything to say that you've completed deciding what type A is. So, you know, this declaration that this is a pointer to some type has to point to this type B, which means we need to sort of be able to pass this through type checking, again, without waiting on all of B's members. That was the whole point. And if I say that we're going to wait on all of B's members for B to make it through type checking, we get a deadlock. So that's sort of the problem. And as I explain it like this, I actually do not understand. If the problem is really as bad as what I've explained, I don't understand how I've been compiling stuff for 2 years. So it must not be that bad. There must be something that I'm forgetting that is supposed to take care of this, that usually works, but that doesn't work in this case. And while I think about that, I'm going to make some tea and get warm, and then we'll see. I need to move my work desk here so that it's right by the fireplace, so I can have the fireplace going as I program. I could turn the desk so the fireplace is behind me and you could see it in the stream. Maybe I'll do that in a future stream. So I'm actually going to restart the program and break here again so I can step into this find declaration and see what it does. But I'm also going to wait for my tea to steep for a second. So how's it going in the stream, people? In the chat? So I have a fireplace, but it is not a wood-burning fireplace here in Seattle. It is a gas fireplace, which is what everybody has now, which is a little bit of a bummer because it's not as much of a real fire. It's like a little wimpy, dinky fire, but it's better than nothing. I'm doing all right. Yeah, it's not only midnight, it's midnight on a Friday. So yeah, there's not going to be a real discussion in the chat. All the cool people are out partying at the club. In San Francisco, at my last apartment, I did have a wood fireplace, which I use sometimes in the winter. And that was all right. Okay. So, like I was saying before, I'm pretty sure that the right solution to all of this is make it so check that types match can yield. However, I want to understand the situation. So, because if I don't understand this compiler, then nobody does. So I want to step through this and just see what all happens. Okay. So here we're just looking up this identifier in the scope. And I don't think this is going to add any dependencies. I think it's just, okay, global scope optimization is true, but we're not going to be in the global scope yet, but we will get there, I think. Or no, we'll get to it in file scope because we're in the same file as it. All right, so current scope we're in has no members. Why is that? Because it's that confuses me because this should be in the scope of this procedure. Oh, because we didn't declare any variables in the body of this procedure, that's why. So we're in this procedure. We're going to navigate upward to find, and I may not step through it all, but we're going to navigate upward to find this identifier. And this has got to go through several scopes just to get out of this procedure. So it's in the body scope. It has to look in argument scope. It has to look in the pre-baked value scope, which is empty because this is not a polymorphic procedure or anything like that. And then it gets to file scope. So it's going to like recurse upward like 3 steps, but whoops, and I skipped past it. But that's just a recursive call to this own thing, and it doesn't do any dependencies. It is just finding the declaration and then making sure we didn't use it before we declared it. That's all this thing is doing. Okay, so that's fine. We found it. So now follow constant import targets is this thing that does the dependencies. And I don't think this has an import target, right? So this is not going to do anything. So depend through import targets, nothing, nothing. Okay. Nothing has happened except that we found the declaration. Now, I don't know why I grabbed the name here. This is one of those things where it's like, oh, what? Because I use it way down here. I don't know. Anyway, so we set that, so this resolve declaration field on the identifier is just like, okay, did you find what this represents? And yes, we did. So we found it. Hope you guys realize all this work that compilers do for you when you just type code. You just type some text and they do all this stuff. It's crazy. Okay. So if it's a lambda, we do some things, but this is not a lambda, so we're not going to do any of that. We return true. Okay, so resolve one ident. Yeah, this is kind of crazy. So we do not add a dependency here. So the way that we decide, well, the way that we decide if we're ready for this identifier is just, does it get its type, which it will. So we'll step through till that happens, right? So we did complete that, right? And then we're looking at that declaration. It is not marked do not resolve, which is a special thing that, you know, we're not going to yield. And I believe it has its type, so we're not going to yield for that reason either. So now, if it's queued, then it's kind of asynchronously happening, which this one is. This is the thing I was looking for. This is the thing I was looking for. That might be kicking in. Okay. So this thing has a queued. We don't depend on ourself in any tricky way. That's what this is checking for. These are not the same pointer. What are the ident flags? They're 0, so we don't have this set. This no size dependency except in lambda body is the thing that would prevent us from depending too much on pointers. That is that thing. But that, I believe, only kicks in when you're saying the type name of the thing, which may be wrong. It may be the wrong way to do it, but that's how it works. It's only for type declarations. This is not a type declaration. This is just, here's the value of the thing. Like these are type declarations, right? You have a thing of a certain type. This is, we just have a value of a thing and we're taking the address of it. And we're not getting a size dependency, but we actually want it. We want the opposite of this flag anyway. All right, so we're not going to set skip. Skip should be false. This is like we're deciding if we should depend on this declaration. If our outer is a declaration, which it's not, our outer is a lambda. So our lambda is depending on this declaration, which is right. But that, like I said, that dependency isn't going to do anything for the purposes of our crash or our assertion because we already know what the type of this thing is. The problem is that something deep inside the type of this thing isn't ready. And at some point I made the decision, like I said, maybe early on in the compiler, that that needs to be able to happen. Now, one way, just to see what happens, I can do some crazy stuff here. So I could just say like A is a texture catalog, and that'll add a dependency on texture catalog itself and not a pointer to it, to this procedure. And then we should compile OK. Of course, we might not compile OK simply because there might be a different problem of the same kind or of a different kind, but let's just see what happens anyway. Well, let's see what we're not yielding on. It's probably something different. If it's not something different, that's interesting information. Let me get rid of our breakpoint because that's slowing us down. The site is editor. Yeah, so this is a different case of the same thing. So it's a very similar case, in fact, right? So we're taking a pointer to shader catalog. Now this is bugging me because you know what? Dude, I had this problem like 2 years ago and I solved it in a certain way. And then I changed the dependency system around and I guess I broke it again, but I somehow never noticed because things always came in the right order serendipitously or something. Okay, so that's enough rambling. Does anyone want clarification on anything? Because what I'm going to do is, well, okay, let me think. If I don't want to make that check the types match procedure yield, what I will do is when I add a dependency on a declaration and I'm in a lambda, I could do this just to test. When I add a dependency on a declaration and I'm in a lambda, if it's a pointer type, then I need to know the actual thing that it's a pointer to. So I need to make a size dependency on that struct. I swear I have something like that in the compiler already, and I probably do, and it probably only kicks in other cases that do not include these for some reason. Okay. Does anyone know what the hell I'm talking about? All right. Oh, Danny O'Dwyer is hosting my channel. What? That's crazy because like this is some serious programming and his audience is gamers, not programmers necessarily. I mean, some gamers are programmers. Yeah. That's fine if you have no idea what we are even doing because I kind of don't either. So I want to go back and find, okay, this stuff. I'm going to put what may be a hack here or what may be correct. And so when I add this dependency, if I'm in the body of a procedure and it's a pointer to a struct type, then I will wait on the struct type. And we'll see if that works. And regardless of if it works, maybe I'll just let that be the solution for now because it's less of a deep structural change. But I will give a good comment of like, okay, well, the reason we did this is because check the types match doesn't yield, but it maybe probably should. All right, so we're in line 4509. Okay, so if we don't skip, we add a dependency. Now, if, oh, but we can't. I may not be able to solve it this way. Because we don't, so in the case that we stepped through, we happen to know the type of this thing that we're putting a dependency on because it went through the pipeline before us, but there is no guarantee of that. In fact, in many cases, it won't happen. But in fact, the randomizer that we did ensures that sometimes it will happen and sometimes it won't. So I can't check the type here and do things depending on what the type is, because we don't necessarily know the type here. What I could do no, I really can't do anything. I would have to invent a weird new dependency type that's like check through pointer if this is a struct. Which is tempting. Which is tempting. Do I want to do that? Oh, on the one hand, it would look like a super ugly hack. On the other hand, there's something a little bit tempting about saying, you know, check that types match is pretty much a leaf procedure, and you should only call it when you're ready to call it, and it'll definitely succeed if you're ready to call it, right? Okay, I'm going to solve it this way, and I'll explain why. The way I'm going to solve it, assuming that this solution works, we may have to backtrack everything I do here, but assuming that this solution works, the way I'm going to solve it probably looks like an ugly and stupid hack, and that may be true. However, because it's an ugly and stupid hack and it's going to have an obvious name explaining what it does, you'll see that it's there, and if we want to walk it back later or change it, we'll be able to do that because it's understood. To change check that types match so that it yields, under certain circumstances, it a little bit opens a Pandora's box, because now like everybody who calls that maybe has to handle a yield if that's really what we're doing, but also, like I said, there's something very comforting about any time where it's like, okay, this procedure is supposed to succeed if you call it. It's not going to fail. I mean, you know, it might return that the types don't match. That's a user level failure, but it's not going to fail at the compiler level, right? And the more of your compiler you migrate to a way where it's like, oh, this might not work right now. Well, as I'm saying that, I'm not as convinced. So all I'm trying to say there is, like, if you put in an ugly hack, you can see the ugly hack later and understand it, right? Something like, oh, this thing yields, it might not be as obvious that it was a choice for that to yield, and that you might get some code morale back. You might get some good feeling in the solidity of your code back if you make that not yield. That's like harder to see, and so it's a little bit of a more irreversible transition of the code. It's not literally irreversible, but it's less likely for you to walk back later if it's not the right thing. On the other hand, if I do the hack version and my opinion after doing it is that yes, it's a dumb hack, then I'm just making the code more complicated in a way that I'm going to have to change later, and that's like busy work kind of a thing. It's inefficient. And I just had an idea somehow that I was going to go check something and then a space. I saw something out the window and it distracted me and I spaced, and now I don't know what I'm doing. Oh, I was going to just check to see how many people call check the types match. It's a lot, honestly. It's, yeah. So like if I really want to make this thing yield, then I sort of have to audit all these cases of it and see if they should yield in any particular case and handle it, which is a lot to do. However, to specifically fix this one bug, I only need to do it in this one case. Yeah. Well, you know what? I'm going to make it yield because it feels like the right thing. And I'm not going to audit all these cases. They will not yield yet, but it'll be easy to upgrade them on a case-by-case basis if they need to. A lot of these cases, it should be impossible to have a yield. Well, I say that now, but really the only place that can try to force a yield is calling procedures, because that's the thing that calls find compatible anonymous member, which is the thing that could yield. So, all right, let's get busy. Let's, so type check arguments is calling this inner there's some outer overloads of this that are supposed to be like nice and just help prep your arguments for simple cases. This is the inner one, so I'm going to just add a yield upon here. I'm going to say ask expression yield upon, and that's going to be an optional argument. So we're going to go into, let's kill this, and check that types match. So silent check is already optional, and now we'll go ask expression yield upon equals null. So nobody has to pass it, and we should just be able to recompile with that. Yep, we succeeded. So that's great. We've got an extra parameter. It's null. Nobody uses it. Now, the people who are going to use it, well, let's run again and hit that assert again. Well, let's handle this right here. So we'll say if yield assert that we were passed a pointer in which to return this result, pass it along. This could probably be shorter. We could probably just pass it directly in there, maybe. And we'll return false, because it shouldn't really matter if we return false or true, because that false or true says, oh, this types match or not, but whoever calls us should realize that is not valid because we're yielding. Yes, this is where functional language people are all like, you should use a blah, blah, blah type. All right. So, the caller is type check arguments. Changes were made that could not be applied. What are you talking about? Code changes. So why did it turn off the syntax highlighting? You guys are crazy. Go back to where we just, oh, come on. It's like they just keep making worse and worse decisions on this thing. I just can't. All right, so now, whoops, let's just recompile. So we should still assert, but now we should hit that different assert. Right, so now we're asserting that we don't have a yield upon, which is exactly right. So, hey, we're trying to yield, but whoever called us is not ready to handle that. So here, we will handle that. So this procedure can yield. So I'm going to say, this is line 1825 of typer. We're going to say I'm going to do the same thing. This all probably doesn't have to be as verbose as I'm making it. Like this can probably, I probably even don't have to declare this. I can just pass my yield upon pointer into here. In fact, let me see if I do that. Yeah. So typically I just pass the yield upon into whoever, and then, yeah, let's just do that. So yield upon, and if someone tries to yield, I believe they will assert if yield upon is null. So if star yield upon, then I believe we'll return false here, right? Oh, we say yield. Okay. If that's, yeah. Yeah. So what this yield macro does is essentially returns false, but before it returns false, it just pokes the pointer to what we're yielding on into a struct so that we can debug or maybe generate error messages about it. Now, in theory, that should solve the problem. Like all that talking for a small change. Do yield. Oh. It's, if, wait, what? What you talking about, Willis? I'm doing this, oh, yield star, yield upon. I don't know why I dyslexically didn't see the star. I'm having more and more episodes of that. Well, let's just see what happens with this. We might hit a totally, we might not solve the problem at all for whatever reason. We might have introduced a new problem. We might have solved the problem, but then we might hit another later assert. Who knows? Okay, that was great. So that was like 2 hours of me talking about stuff for a 4-line fix. But that's what happens when we're trying to, whoops. That's what happens when we're trying to be careful about what we're doing. And I hope a little bit of that discussion was useful to people. This is not even all the compiler bugs that we're trying to chase down, because there was that one memory corruption bug, but this is most of them at this point, so it's been a successful day. The other, if you didn't see the previous streams, the other ones happened in the previous streams. Any